So question 19 is like a very interesting question. So we have like three circular arcs of radius 5 units that bound the region shown. We're given that arcs AB and AD are quarter circles, and arc BCD is a semicircle. We want to know what is the area in square units of the region. So basically, the idea is what we can do is like we might like at first like maybe this question is a little tricky, right? We might at first look at the question, we're like, oh, notice that like this is like a very curved region, right? Like you have like this curve here, and another curve here. And we know that whenever we have these circular curves, most of the times in our answer, we're gonna have like a pi, right? Like we're gonna have something times pi that represents the area of like some circular region or something like that. So we might think the answer might be like B, like D or E, like if you were to guess, but like it turns out it's not any of those answers, which might be like pretty surprising. The idea to look at this question is like we're given that arcs AB and AD are quarter circles, right? So we're given that like arcs AB and AD are quarter circles. So basically, like I can say like this red quarter circle here and this red quarter circle here, they're like quarter circles, like because that's what they're given the problem, like right? Arcs AB and AD are quarter circles, and arc BCD is a semicircle. So we know arc BCD is a semicircle. So the idea is like, okay, so if the idea is like, if I were to like, let's color this region like blue or something just to distinguish them. If I were to like split the region, if I were to like draw this line here, like I were to draw a line BD, and if I were to draw like this line down, I can split this semicircle. I could split it into two quarter circles, right? I could split it, and let's color this quarter circle red, and I can color this quarter circle blue. So this semicircle BCD, I could split it into this red quarter circle and this blue quarter circle. But like notice, like I can kind of like imagine translating this like this like red quarter circle and like putting it into here, and translating this blue quarter circle and putting it into here. So I can imagine like taking the semicircle, like chopping it in half and like translating those pieces. And then we get a new region, which is this like green rectangle. And this green rectangle has like the same area as like the original shape, because we just simply translated the red and blue quarter circles around, but we didn't change like the area of the region or anything. So we know that the radius of this quarter circles and the semicircles are all 5. So this length here is 5. This length is 5, and this length is 5. So basically, all we have to do now is find the area of this like rectangle. And this entire thing has like length 10. So the area of the rectangle is 5 times 10, which would give you like 50 as the correct answer. Yeah, so that would be choice C, and we'd be done. So I think this is like a pretty interesting question. The fact how like even though we had like so many different like curved regions, we have like you know, we had quarter circle arcs, semicircle arcs, like we had a lot of arcs that were joining together. And we want to find the area of that resultant region, but like we found that the answer, it turned out to not have any pi in it. And that might be like kind of surprising, right? Like a lot of times when we're working with curved regions, we'll have pi in our answer. But clearly, we found that we were able to like kind of imagine cutting the semicircle in half into 2 quarter circles. And then when we translated the quarter circles, we found that the area of the region that we wanted to find was equal to the green rectangle. So that was like very convenient, and we know how to find the area of rectangle. So, that was a pretty cool problem, I guess.